Hello, sir.
Yes.
So, sir, this is chapter 4,
Yeah, this is chapter 4.
but in our Blackboard, this file is not visible. So, this is section 4.5, right?
This is right now I'm in 4.4. And again, today I'm going to start 4.5 as well.
But in
I think
4.4,
4.5 is there, right?
mm,
I can check it.
uh,
Yeah, I'll check it.
okay.
And if there is not there, I'll upload it. Okay.
So
I
let me
think it
check
should
right
be there.
now. Yes, sir. Yes, sir. It is there. Yes.
Okay.
Okay, sir.
Thank you.
Okay. Thank you so much, sir.
Okay. Okay. Shall we start? Last day I stopped from here. Actually, this is little bit you know boring because we have to in this chapter, sorry, section 4.4 and 4.5, we have to discuss distributions. So it is a little bit boring, but uh, once you have to solve the problems, you will need these distributions. Okay. Okay. We start from here. We start from gamma distribution. Gamma distribution. So if you remember gamma, this is the this is the gamma distribution, and this we call gamma function, which is this one. Uh, uh, okay. So since it is really hard to find the CDF of gamma, we have an alternative method which mean we can use our gamma table or gamma distribution table. So mean and variance. Mean of the gamma distribution is alpha times beta. Variance is uh, alpha beta squared, right? So first question was find alpha and beta, and the second one is find the probability of uh, transfer time exceed 50, which means x greater than or equal, it doesn't matter, greater than or equal 50. So you can find this using negation, which means probability of x less than 50, right? So this part here you can find using your gamma table. Okay, so let's check this one. See here, you need to find this. Okay, uh, so probability of uh, sorry, 1 minus probability of x less than 50, right? So this x mean, I told you we cannot use x, we use x over beta. So which means this one, sorry, this one. See here, this is our CDF, x over beta comma alpha. Okay, so alpha is you can see here. So what you have to do is you have to divide both sides by beta inside the bracket. Okay, so you will get this x over beta less than what is beta? Beta is 10. So 50 over 10 is 5. Okay, so x over beta, what is x? X is what? So what you have to find here? Less than 5, right? So see, don't confuse it that here in incomplete gamma you have to use, actually you have to find this, and you have to use this to find p x less than or equal x. Okay, so here 1 minus, okay, you have to find f of, right, x over beta, which is 5, right? We need to find this one, right? So 5 comma this is alpha, this is your x over beta. Okay, so once you go to the table, you will see x values, which mean this piece. Okay, and alpha values. I have the table here. So x over beta, which means x is 5, alpha is 4. So you can find x values from first column, which is 5, right? Alpha, which is 4. So you come down, go along this axis. Okay, this is your value. Clear? Okay, which means this piece, okay, the piece which I mentioned here, it is 0.735. So 1 minus 0.735 is 0.265. Okay, so again, don't forget this piece. It is not just x, it is x over beta. So once you need to find this x value, which means this x or this x, which means x over beta. Okay, if x is 500, beta is 10, so that value is x, that value is 50, right? So 50 we cannot find here, but that's how we get that x values. Okay, most of the time you will, I think, yes, you will be able to manage x values and alpha values. Always we try to stick with this range. Okay, alpha up to 10 and x values up to 15. Okay, so don't worry about that. Next one, last one is within this range, 50 less than or equal x less than or equal 80, right? So again, you have to transform it like to this form. Divide each term by beta. Okay, so beta is 10. So like this, you can see 50 over 10 less than or equal x over beta less than or equal 80 over 10. Okay, 10 here is beta. Okay, so once you do that, you can simplify what you need like this. Okay, so now divide this into two pieces, right? It's like if you have this is your gamma distribution. It is something like you need this much, right? You need this area. This is 5, this is 8, something like this. Okay, so what you have to do, first you have to find this area up, from its beginning to this point, and next you have to find this area from its beginning to 5, then take the difference. That's what they have done here, right? Area or the probability up to 8, first one. Okay, second one up to 5. So get the difference, you will have the, you will be having this exact answer. Okay, so how do we find this up to this point? F8 4. What is 8? X over beta is 8, alpha is 4. This is alpha. Okay, again here 5 as well. Okay, go to the table, find this. I'll show you how to find this one. Okay, 8 4. So x over beta is 8, which means this one, the other one is 4, right? Yeah, 4. And this is the 4 column number 4. So this is the value 0.958. See, 0.958. Using the same way, you can find this value and find the answer. Give the answer what they need. Okay, clear? Don't forget this step from here to here. Okay, divide them by beta. Okay, okay. That's about the gamma distribution. Next, I'm going to discuss the next gamma family distribution, which is exponential distribution. Okay, if you remember, we had three distributions which are gamma, exponential, and chi-square. Okay, let's talk about the second one, exponential distribution. So if x has an exponential distribution, then a random variable x has an exponential distribution, then its PDF is like this. Okay, it has only one variable which called lambda. Okay, so as you can see, this is the PDF, and this exponential distribution defined on uh, all real values, all positive real values. Okay, defined only for x greater than or equal 0, starting from 0. So 0 is here. It's something like this. Okay, so this exponential distributions we call exponential decays, because this exponential distributions always goes down like this. I don't know where it start, but it goes down something like this. Those we call decays. Okay, it's going down. Okay, otherwise, which mean all values less than 0, function is 0. Okay, which means for these values function is 0. Clear? Any value, any x value less than 0, a PDF is 0. Okay, so simply you can find the CDF by integrating it, right? From where to where? See, x defined from 0 to where? Infinity, right? What is the PDF? Lambda e to the power negative lambda x and dx. Okay, with respect to ds, sorry, not infinity, up to x. Oh, I'll use it y, otherwise you will confuse. Okay, so 0 to any point, any point, once you integrate, you can find the CDF of this exponential distribution, which is this one. See, once you integrate this, you will get this answer for all x greater than 0. All x less than 0, it is 0, because you have 0 here. Okay, so once you need to solve the problems, you can use either your integration integration method, or simply this one, simply this CDF, what they have done. In here, what you have to do is simply replace this alpha and replace this lambda and x. Okay, or simply you can integrate it and get the answer. It doesn't matter which method you use, you can find the value. Okay, for the CDF. Expected value, which is 1 over lambda, and variance 1 over lambda squared. Okay, once you have a distribution which in your problems, once you have a distribution which you already know, okay, uh, the advantage is you already know what is the mean and variance, or what is the expected value and variance of that particular distribution. Okay, so you don't have to find it by integrating or doing other method. You simply, if you remember that, simply you can use the uh, equations or formula for that, like this. Okay, if you don't know about the distributions, then you have to do the integral stuff and find the mean and the variance. Okay, clear? So these exponential distributions are always decaying. Okay, like this. It doesn't matter where it start, it always decaying, and it goes to 0, infinity, or sometime before the infinity, doesn't matter. Based on lambda, because lambda is the only parameter, uh, its shapes change. Okay, when lambda goes up, which means 10, 20, 50, 100, it starts from that value. It starts from very close to that value. Okay, where you can see that here. See, lambda equal 10, which means it starts from just before 10. Lambda 5, just before 5, something like that. Okay, clear? Okay, check this example. X is the time between two successive arrivals. Okay, lambda given, which is lambda equal 2. So what is the expected time between two arrivals? What is the expected time? Expected value of x, sorry, expected value of x is what? 1 over lambda. Okay, so 1 over lambda means 1 over 2, which means 0.5. Okay, clear. X less than or equal 4, which means what? I'll use the integration method. Okay, I'll use integrals. So once you need to find this, you have to integrate your PDF, okay, from less than 4, right? So from 0 to 4, right? So lambda is 2, lambda e to the power negative lambda x, right? 2 times x. So this is your PDF. Okay, this is your PDF. I replace the lambda because you know lambda is equals to 2. Clear? So once you integrate this, you will get the answer. Or simply you can use the CDF which they have given in this here. See, fx lambda is 0, which is not defined, which means less than x values are less than 0. When x values are greater than or equals 0, it is 1 minus e to the negative lambda x. Okay, or 1 minus e to the negative lambda x. I think this is easy. Only thing you have to do is plug the values. So 1 minus e to the power negative lambda, which means 2 x, x is 4. Okay, so in between 2 and 4, there is a multiplication. So 1 minus e to the power negative 8, right? So you have to use your calculators and do this job. Okay, clear? Okay, I'll show you that answers in the next slide. See, e to the power, expected value, it is 1/2. X less than 4, here they have do the integral stuff, but simply you can use the CDF easily. So this is the answer. Okay. Then once you need to find the range, probability of 2 less than or equal x less than or equal 5, then again what you have to do, if you are using integrals, easily you can replace these lower bound and upper bound using 2 and 5 and integrate it. That's it. Otherwise you have to use your CDF twice, which means, let me erase this, which means okay, I'll use bracket for this piece. Okay, x less than or equal 5. For this piece you have to use what? 1, it is 1 minus e to the power negative alpha, which means 2 times alpha x, right? So is x is 5. Clear? Minus this piece. Here 2 less than or equal x, x greater than 2, right? What you need to find? Whatever just before the 2. So 2 is here, 5 is here. You have your distribution like this. You need in this problem you have to find the area from 2 to 5, right? So what you have to do, you have to get the area from which, since this is start from 0 to 5 and then 0 to 2, right? Then you can find the area what you need, right? Same thing here. So first one, this one, 0 to 5, it is this area. From 0 to 5 is this. Now you have to find the area from 0 to 2. Okay, so again 1 minus x is 2, lambda is also 2. Okay, once you simplify this, you will see 1 minus here also -1, so 1 cancel out and this become positive. So e to the power -4 minus e to the power -10, right? Yeah, this one. See, once you use the CDF, you can easily get that value. Clear? Okay. So last one. Once you need to find greater than something, okay, easily you can find this guy. How? 1 minus its negation, x less than 1. Less than 1 you can easily find 1 minus using its CDF, right? 1 minus e to the power negative lambda times x is 1. So 1 minus 1 is 0. So this become e to the power negative 2, right? So I think the answer is this one. Yeah, clear? Okay, any questions? Or simply you can use what you already know, the integration stuff, integral stuff. Okay, you have to integrate it. Here, since it is greater than or equal 1, it goes from 1 to infinity, because infinity is the maximum you can get. So you have to integrate over 1 to infinity. Okay. Okay, this is distribution. The third one, I mean the last one of this, last one which belongs to the gamma family is chi-square distribution. But this chi-square distribution I'm not going to discuss in the class. I have already uploaded this PDF files. So if you would like to see this, you can check it. But I think there is no homework question from chi-square distribution, as well as I'm not going to uh, give you any questions for the mid exam or final exam from this chi-square. Okay, because you have to do a little bit more work to use this chi-square, because you have to use degree, or you have to find degree of freedom, something like that. So here we mean degree of freedom. Chi-square distribution denoted by chi square. Okay, this is the symbol we use for chi. Okay, chi. It's not x. It is like something like this. Okay, so so this is chi square. Okay, so if you would like, if you want to check this, you can go to the note and find. And if you need more details about this distribution or more problems, please email me. I can give you more details as well as questions. But again, I'm not going to ask you any question from chi-square distribution for your mid exam or final exam. Okay. Okay, this is the last of the last distribution of this chapter. If you don't have any question, I can move into last section, which is uh, okay, let me share it again, which is 4.5. Again, 4.5 we have distributions. Okay, so as I mentioned, 4.4 and 4.5 full of distribution. So already we've learned, except chi-square, we've learned 3 important distribution: normal, gamma, and exponential. Okay, then we have few distributions here as well. Those are continuous distributions. Okay, first one is Weibull distribution. Okay, this is not in this section. We don't discuss something in gamma family. This is not gamma family. Okay, this is something else, not belongs to any family. Okay, so Weibull distribution. If X has a Weibull distribution with parameter alpha and beta. Here we have 2 parameters, alpha and beta. Okay, so Weibull distribution, the PDF of PDF of the Weibull distribution is this. Again, this Weibull distribution defined greater than 0, greater than 0. Okay, so less than x less than 0, it is 0. See, first one. But x greater than 0, it has its own PDF, and it goes to up to infinity. Clear? So you have to remember this PDFs, at least these PDFs. Okay, so once you know the PDFs and their rates, their range, where it start, where it ends. Okay, then you can find the CDFs simply integrate it or do your calculation and you can find the CDF. So at least, sorry, at least try to remember the PDF of each of these distributions. Okay, so you can find expected value and variance simply integrating uh, this PDF. Okay, so here you can see this is the expected value of x, which means mean of Weibull distribution, or simply we call expected value. Beta times this is the gamma function. Do you remember gamma function? This is the gamma function. Gamma 1 plus 1 over alpha. Okay, variance is a little bit longer than that. Beta squared within bracket gamma 1 plus 2 over alpha minus gamma 1 plus 1 over alpha squared. Okay, here you can see this piece is what? Once you multiply inside by beta squared, you will see it is mu squared. Okay, this is mu squared. Once you multiply it by beta squared. Okay, so there are some similarities, so you can. I think the best way is to remember this one. Okay, otherwise it takes some time to get this value from its PDF. Okay, so it doesn't matter if you remember this, you can simply apply this. Since you are in this course, since you are doing since you are using notes, it's open notes for the exam, so you can simply use your notes. Okay, okay, so Weibull density curve is something like this. If you check huge values like 10, 5, you will see it is like this. Okay, there is an there is a special case if alpha and beta equals 1. Okay, if alpha and beta equal 1, it becomes exponential distribution. Okay, so there are few distributions. Once we change their parameters, they will change to another distribution. This is an example. So Weibull distribution, when alpha and beta equals to 1, it becomes it becomes the exponential distribution. Okay, so keep that in your mind. That's fine. Once you check the uh, values like alpha 10, beta 0.5, something like that, you will see that curve how it changes. See, this is start from here and goes like this. The second one, alpha 10, beta, I think it is 1, right? So it starts from here and go like this. Okay, these are different. This is not a one curve. These are 3 curves here. Okay, this one, and this one. There are 3 curves. Okay, different alpha and beta values. Okay. Okay, CDF of the Weibull distribution is this. Again, you can find the CDF using 0 to x, the PDF of Weibull distribution. Okay, CDF of the Weibull distribution over dx. So clear, you can find this, but you don't need to find it actually, it's given here. So since it defined it starts from 0, less than 0, it is 0. Okay, probability is 0 for all x values less than 0, and this is the CDF for all x values greater than 0. Again, you can use this to find whatever you need. Okay, clear? Okay, let's check this example. So all questions are like this. Okay, from Weibull distribution, gamma distribution, exponential distribution. They have given, okay, this is This variable is exponential distribution, or x is an exponential distributed, something like that. So you know what is the distribution you need to catch. Okay, so alpha beta given, parameters are given. X is Weibull distribution. X belongs to a Weibull distribution. So you know what is the CDF. So CDF they have given. So don't worry. I mean, they have copied the CDF from the last page here. What you need to find is x less than 6. Probability of x less than or equal 6. Simply plug the values, right? E to the power 1 minus e to the power x is 6 over 3 squared. So simplify it, you can get the answer. Same as the previous case, once you need to find something like this within range 1.5 to 9, okay, 1.5 to 9, let's say Weibull distribution is like this. So 5 to, oh sorry, 1.5 to 9. You can find area from 0 to this point and area from 0 to this point. Take the difference. Okay, that's what they have done here. This is the probability from 0 to 9, which means probability of x less than 9 is this one. This is the probability of x less than, this is less than 9, less than or equal, that's fine. This is probability of x less than 1.5. Okay, once you get the difference between these two, you will get the answer. Okay, please try to always, okay, I recommend this one. Always try to use the brackets. Okay, any brackets to isolate terms. This is a one term and this is a one term. In between these two, there is a negative sign, minus sign. Okay, so if you multiply this second term by this negative sign, you know what will happen, right? This become positive, this become negative. So don't confuse with that. Please use brackets, otherwise uh, you will mix everything and your answer will be wrong. Okay, clear? Again, greater than something, you can find 1 minus less than that value. So easily you can find that. Okay, 1 minus brackets 1 minus e to the power negative, it is 2 over 3 squared. See, here you have negative sign, so this negative multiply with this, it becomes negative. So 1 1 cancel out, e become positive. Okay, so you know how to do that. Okay, those are just math. Only thing is, don't uh, mess with these brackets, okay, or signs. Use brackets always. Okay, log normal distribution. Again, still we have discussed distribution. Distributions we've done Weibull, now log normal. Okay, log normal distribution is little bit useful. Okay, why it is useful? It has a similarity from normal distribution. Okay, see, it is like log normal. Okay, so it has a relationship, I mean direct relationship with normal distribution. Okay, okay, you will see that x always, since this is log values, okay, from the name, see, log normal, so you know log values are positives, positive values. Okay, so non-negative, same, because we need positive value, same as other distributions, we have x greater than 0. So x is log normal distribution if it satisfies something like this. ln x is ln x is normal. Normal means normal distributed. Okay, so if this is normal, which means normal distributed, then this guy here has a log normal distribution. Okay, clear? So we can use this log normal distribution, or we can derive the log normal distribution using normal distribution with parameter mu and sigma. Do you remember that? Mu is the mean, sigma is the variance, sigma is the standard deviation of the normal distribution. Okay, so using those three parameters, those two parameters, and next we can define CDF of log normal distribution. It defined x greater than 0. See, x, if you remember normal distribution, I can write it here. This is the normal distribution. PDF of PDF of normal distribution. Okay, so all x greater than 0 or not. See, do you remember what is the range of the normal distribution? Negative infinity to positive infinity. Okay, okay, what was that? 2 over 2 pi sigma e to the power, yeah, exp x minus mu divided by sigma squared. Oh, sorry, 2 times sigma squared here is squared, right? So this is the normal distribution. Okay, so they are very similar. See, x here, ln x, because variable is log normal. Okay, variable is ln x. Here is similar but is different. Okay, because of the ln, because of the log. Okay, so it is 0 if x greater than sorry, x less than 0. Okay, okay, log normal distribution is something like this. It is again a skewed distribution. Okay, skewed distribution. Check this one. Expected value of log normal distribution is this one. E to the power, this is e to the power, everything e to the power, exp, you can write it like this, exp mu plus sigma squared over 2. Okay, so everything e to the power. Okay, same here, you can write it exp, variance exp 2 mu plus sigma squared done, then times e to the power sigma squared minus 1. Okay, clear? Okay, how do we find probabilities? I mean CDF using this log normal. To do that, you can use normal distribution. Okay, you know ln x has normal mu sigma, sigma squared, variance sigma squared, right? It has a normal distribution with mean mu and variance sigma squared. Clear? Using that, we can derive CDF of this guy. Okay, we need to find probability of capital X less than or equal simple x. What we are doing here is take the ln or take the log both sides. Okay, so you can see this is going to be simple x. Okay, this is simple x, doesn't matter simple or capital. Okay, now do you next do you remember how we standardize our normal distribution? Using x minus mu divided by sigma. Okay, same here, standardize both sides. Okay, simply like this, ln x here, and you have ln sorry, this is capital X, and ln x here. Standardize both sides, minus mu divided by sigma, minus mu divided by sigma. Okay, so this becomes c. Do you remember? And this stay same, it stays same. Okay, here you have probability for both of them, you have probability. Okay, same here. See, now you have z less than or equal ln x minus mu divided by sigma. If you remember how we denote the CDF of standard normal distribution, because this is the standard normal variable C, okay, we denote by capital pi, okay, not F, we use different notation, okay, this. So whenever you need to find the CDF or cumulative density values up to a particular x value using log normal, you can use this. Once you know the x value, you can take ln x minus mu sigma. Okay, mu sigma came from normal distribution. Okay, okay. Check this example, then you can understand what I was talking about. Uh, okay, just pick the necessary information. Okay, log normal distribution. We have log normal distribution. Sulfur dioxide concentration. Okay, mu sigma given. Mean and standard deviation. What is the mean and standard deviation? You have to go back to that this one. Oh, sorry, this one. Where? This one. Sorry. Plug those mu and sigma and find mean and variance. Okay. Yeah. Next slide, you can see the answers. Let's take this. This is the important one. What is the probability that concentration is at most 10, which mean x, right? Here x mean our log normal distributed variable. Okay. At most mean less than or equal 10, right? So we have to find this. To do this, what you have to do? Do the normalization stuff. So here x is our log normal distributed variable. You can use ln both sides. Okay, I'll show it here. So you have to find this. So take ln both sides. Probability of ln x less than or equal ln 10. Okay, then standardize minus mu divided by sigma. So p ln x minus mu divided by sigma less than or equal ln 10 minus mu divided by sigma. Okay, this piece become what? It becomes C, right? See this one. So this becomes like this. Once you simplify this piece, it gives you this value 0.45. Okay, so how do you find 0.45? Go to the normal table, find this value. That's it. Okay. Here doesn't matter. Same as the previous cases, you can do the same thing for both sides. I mean, all three values. Middle becomes C. See, it becomes C. So you have very similar what we have done in the normal distribution. Okay. So after this point, it is easy. You have to use the knowledge from this normal distribution. Okay, since these values are C values, so go to the C table and find the probabilities like this. Okay, so I'm not going to explain this again because we have done it in the normal distribution, especially standard normal distribution cases. Okay, clear? It is easy, right? Okay, this is the last one. This is the last one, which is beta distribution. Okay, beta distribution. This is a little bit longer than other distributions. Like it has 4 variables. Okay, alpha, beta, and both alpha, beta are greater than 0. Okay, alpha, beta greater than 0. Okay, and there is another 2 variables called capital A and capital B. Those are limits. Limits mean capital A means the lower value, B is the highest value. Okay, so once we define the CDF of beta distribution, if all x values less than 0, I mean all x values within this range A and B, distribution is defined. Distribution is defined. So distribution is like this. Otherwise, which means any x less than A, okay, otherwise means x less than A or greater than B, it doesn't define, which means it's 0. Clear? Okay. So this A and B, well, this A and B uh, can be positive or negative. Okay, it's possible. Capital A and B can be negative or positive. There is a special case here. If A is 0, B is 1, it gives us the standard beta distribution. So once you plug A equals 0, B equals 1, you will see this goes to 1. This becomes x minus, sorry, this becomes x, right? And this becomes 1 minus x to the beta minus 1. Okay, something like that. You can simplify it. That one we call standard beta distribution. Okay, so mean here, variance here. Try to use this without worrying about how to derive this. Just use this one. Okay, if you need a CDF, what you have to do? Integrate it from its starting value to that particular x value, beta PDF or dx. Okay, there is no other way. You have to use your integral skills. Okay, clear? That's
Okay,
it.
sir. Thank you.
Okay, that's it. This is the end of the chapter 4. If you have any questions, I mean, these are the, I think, altogether there are 7, but since I remove chi-square, you have only 6 distributions to deal with. But doesn't matter about the distribution. You have a good skill to integral, then you can find your CDF or other values. Okay, but remember, try to remember PDFs of each distribution. Okay, that will help you to do your calculations fast. Okay.